Hey, welcome back everyone to Number Buddy. My name is Buddy. Today we're going to be continuing with trigonometry. We're going to be continuing with trig functions. Last time we learned sine, cosine, and tangent. Today we're going to be learning secant, cosecant, and cotangent. They're going to be very similar, just flipped. You'll see what I mean. So, we learned how to draw an angle, form a triangle, and then look for what the opposite or adjacent or hypotenuse is with respect to the angle that we're putting in as our input from that angle's perspective. So let's start from the same idea. Let's say this is our angle. Theta represents an angle, and we're still working in degrees for right now. Let's look at a new thing that we call secant. Secant is going to work a similar way. We still have an angle input, okay? What we need to know about secant is that secant is hypotenuse over adjacent. Now, you may be noticing that is the exact flip or reciprocal of cosine. Whereas cosine is adjacent over hypotenuse, secant is hypotenuse over adjacent. So another way to think about secant is that secant of some angle, and I'm going to start using this abbreviation theta as a placeholder for an angle. Secant is the same thing as taking your cosine, except doing 1 over your cosine of theta. So in other words, when we do 1 over a cosine or 1 over any fraction, you flip the fraction. You turn it into a reciprocal. This is like saying 1 over adjacent over hypotenuse. And maybe you've learned in the past that when you divide by a fraction, it's like multiplying by the reciprocal. So we end up with just the reciprocal. Okay? So let's take this example that we have written out here or drawn out here. Let's say this theta is 60 degrees that we're starting with, okay? We know this is our right angle. We know this is a 30-degree angle up here, but if we want, say, secant of 60 degrees, we're looking at this angle down here, and we're looking at that perspective. So, from this perspective, what is the hypotenuse over adjacent? Well, hypotenuse isn't going to change based on perspective. Only opposite and adjacent are. So for hypotenuse, it's going to be whatever the length of this side is here, right? Now we talked about what the lengths of sides are, or we at least talked about what the ratios of sides are. And we said the ratios of these sides, in a 30, 60, 90 triangle, across from your 30-degree angle is your base unit of 1. Your other non-hypotenuse side is going to have root 3, and then the hypotenuse is going to be 2. So our ratio of our hypotenuse to your adjacent side is always going to be 2 over 1. Okay, so this is our adjacent side, this is our hypotenuse, and this is our opposite side from the perspective of that 60-degree angle. So do we see how hypotenuse over adjacent is going to be 2 over 1? Which means that the secant of 60 degrees is 2 over 1. We could have done this by saying, okay, if we want to know secant, we could have said, what is the cosine of 60 degrees? And we could have looked over here and said, cosine is adjacent over hypotenuse. And we could have said, okay, from 60 degrees, this adjacent side is 1, and the hypotenuse is 2, right? And then look down here and said, oh, secant is 1 over that cosine. So 1 over 1/2 is like 1 times 2 over 1, and we would have just gotten 2, right? And then 2 over 1 and 2 give us the same thing. Cool? So these are our relationships. Secant is hypotenuse over adjacent. Let's look at what the ratios of cosecant are. Cosecant we're going to abbreviate as CSC. Well, cosecant corresponds to hypotenuse over opposite. So if cosecant corresponds to hypotenuse over opposite, what is that a flip of? And hopefully we can see that it's a flip of sine. So if we take sine of theta, and I'm going back and forth between writing in sine of an angle and sine of theta, because I want us to see that theta represents angles. The thing to be aware of is that for secant and cosecant, there's secant and cosecant, and there's sine and cosine. But cosecant goes with sine, and secant goes with cosine. So it's just something to write down and get practice doing, and in time it'll be second nature. So let's say we wanted to do cosecant of this 60-degree angle. There's two ways we could do it. We could say, okay, what's the sine, and then flip it, or we could say, what is the hypotenuse over opposite? Typically what I do is I would take the sine. It's easier for me, in my mind, to only have to remember sine, cosine, and tangent, and to know that I can always flip them whenever I need to. So I would have said sine of 60, okay, look at this one. We know it's opposite over hypotenuse. Opposite is root 3. Hypotenuse is 2. So then to make it fit here, we would flip it, and it would be 2 over root 3. And that's how we would find cosecant of 60 degrees. Cool? Last one that we would want to work with is cotangent. So cotangent is kind of nice because cotangent goes with tangent. So cotangent is adjacent over opposite. So in terms of our original 3 sine, cosine, tangent, this one is going to be 1 over tangent of that same angle. The thing to notice is that tangent goes with cotangent. But that's the only one that does that. Tangent goes with cotangent in that you can flip tangent to get cotangent. But if you flip cosine, you don't get cosecant. If you flip cosine, you get regular secant. And if you flip regular sine, you get cosecant. Okay? Something just to be aware of. It'll come as you start to do more practice. But again, same thing. If we want cotangent of 60 degrees, we could go adjacent over opposite and go directly as 1 over root 3, sorry. Or we could go what's tangent of 60 degrees. And tangent of 60 degrees would be root 3 over 1. So then when we flip it, we get 1 over root 3. Something to point out that you need to be aware of. Later on, we're going to see things that look like this. We're going to see things that look like tan inverse of some angle. In regular math, you've learned that if you take x, and x to the negative 1 is 1 over x. You've learned that maybe in algebra when you did polynomials, when you were doing exponents, things like that. Again, if you haven't, no problem, we'll make a video over it. But one thing that's a little bit tricky, and it's not so tricky once you get used to it, but one thing to make note of is when we're talking about trig functions, this is not equal to doing 1 over tangent of an angle. If you were to do this, tan negative 1 to theta, that you may see later on, and as a matter of fact, you will see later on, that's what's called an inverse trig function, and we're going to get to that later. Right now, I just want to point out that tan negative 1 of theta is not the same thing as saying 1 over tangent of theta, okay? Okay, let's get a bit of practice. Let's say I wanted you to tell me what is the secant of 315 degrees. Step 1, like always, find where 315 degrees is, okay? If we know 90, 180, 270, and 360, we know 315 has to be somewhere in quadrant 4. Okay, and as a matter of fact, we can do some math and see that 315 is 45 degrees less than 360. So this angle in here that we would draw is 45 degrees. Notice I'm giving you a lot of special right triangles as your angles, which is really all we need to be concerned about right now as we're learning these basics. We remember that in a 45, 45, 90 triangle, our ratios are 1 to 1 to root 2. And because this triangle is oriented facing downwards, or at least the vertical part of it is facing downwards, this side is going to be -1. Okay? So if we want secant of 315, secant goes with 1 over cosine. Okay? So I'm actually going to ask you, what is cosine of 315? And we can look at this triangle and say, okay, cosine is adjacent over hypotenuse. Okay? The adjacent side is 1. The hypotenuse is square root of 2. Cool? If that's our cosine, secant is 1 over that. So secant of 315 degrees would have to be square root of 2 over 1, or just square root of 2. And there we have it. The same idea is going to work in a triangle in any quadrant using any of secant, cosecant, or cotangent. Okay, so now we have all 6 main trig functions in front of us, and we can see their relationship, and we can see what sides are the ratios that correspond to each function. So next time, maybe we'll do some practice on solving triangles that you're given some piece of information and you want to know more information about the others, and we might start to get into triangles that aren't special right triangles. So as always, let me know if you need something explained a bit further, if something could have been more clear, and until next time, my name is Buddy. Keep learning.